It's quite a mouthful of a title. You better read that rather than me. But about myself, I'm a VP of Engineering at AppCity. We are a startup based in SF and India. We are making life of developers easy by generating infrastructure as code for them so that they don't have to write it by hand. I'm a polyglot developer myself, been working in industry for almost 19 years now. I'm very passionate about automation, build, CI/CD, and DevOps, which led me to write the book on Gradle itself. Those who are working on Java or JVM related tech might know about Gradle. I contribute to a bunch of open source projects. You can follow me on GitHub. I'm not very active on Twitter though. Let's begin. This talk is based on my own experience, and I'm going to summarize some best practices for developers, DevOps engineers, engineering managers, or architects. And although it is about being vendor agnostic, it is not to mean offense to any vendor as such. I love most of them. So let's start with how the vendor lock-in creeps in, like how you start getting stuck into vendor lock-in. This is again based on true story of my previous startup or the one before that. So a tale of a startup. You typically are in frenzy of rolling out new features almost every day. And the key there is like to make selections every day. You have to make so many choices. You are required to ship fast. And we were required to deliver content which was unstructured. So we chose managed NoSQL database, and that was a great choice. We chose DynamoDB on AWS. We had within 2 years, we went from a startup to a scale up. We had 20 million monthly active users, and we were serving around 1,000 requests per second, which is quite good scale, with API latency of around 70 milliseconds, which was again good, and lot of credit goes to DynamoDB for that, because we were able to use DynamoDB at latency of 5 to 8 milliseconds. But then suddenly things starts changing. First, it was very difficult to operate that, particularly for BI analytics kind of use cases. We had to copy all the data to Redshift. As a company, we were going to switch to GCP. We had to use BigQuery and bunch of stuff. Now, all the things that were working well for us went against us. GCP gave us good discount, but since our particular service or backend was tightly coupled with DynamoDB, we could not migrate. Essentially, we were locked in. So we had to miss the opportunity of like taking that discount, and we were locked in basically. So lock-in, how do I define that? Is like cost of making the switch. There is no vendor holding you at gunpoint or putting you behind the bars there, right? It's all about the cost, that how much does it take or how much effort does it take for me to change the provider. In this context, we are only going to talk about cloud providers right now. I'm not talking about other kind of services. So why we want to go cloud agnostic or vendor agnostic here? Because the costs are rising. Once you lock in, you stop getting any discounts. So it's always good to have your options open, so that if you find something cheaper at scale, then you can easily migrate to that. There has been a trend in industry now that people are doing a reverse migration also. If you follow DHH, the creator of Rails, they moved their entire company back to data center. Similarly, some other startups have done that as well. So save yourself some future trouble and might as well design applications in vendor agnostic way. So, but when it is not really suitable, when you are just writing a proof of concept, you are not really sure whether it is going to work or not. When the time to market is extremely important, you don't really want to care about agnostic, you just want to go fast. And you have otherwise infinite supply of resources that you can rewrite anytime, so you don't care about that. So what is a decision here that we are making? We are choosing some cloud provider. That should be a conscious decision. For example, I'm using Google Slides right now to present. Am I logged in or have I made a choice? I have made a choice here, but if I want to export it out in PowerPoint, I can very well do that. So I don't consider that as a lock-in. I'm just using something consciously. But there is another class of decisions that you end up making, which are accidental decisions that you did not even realize that you are getting logged or you are getting trapped basically. And again, taking perspective from different personas here, what do people care about most? Let's say developers, they care about new and shiny things. They read something on Hacker News yesterday, they want to implement that today. They want something that looks great on their resume. No offense, I'm a developer myself. Engineering managers, what they care, or management particularly, what they care about, how cheap it is to operate. Will I find people who are going to support this? What the DevOps or SRE persona wants, they want stability. Is this like supported in production? Does it have nice operating metrics and all those things? They want to have finer control over things. So different personas have different priorities, and one of them ends up making a decision, which is where things fail. So one very classic syndrome that I have named it, so I don't know what it is called, but since we already use, that's another trap that you can fall into. Since we are using this anyways, let's just use this as well, because that comes by default, and that is a common argument you will hear. Why add any card to another service provider? We are already using X, let's just keep using that, add that service as well. Oh, the example code that I got only mentioned using X with Y, so I just chose that. These are all the real reasons that people end up giving. Just wanted to list some examples here, again, not to offend anyone, but since we are required to use API gateway, and Lambda requires them basically, so let's just use the AWS API gateway for all the services. Now, that is not the rationale you should go with, right? Or since I was using Firebase, let's just use Google Cloud Functions because we want to process some data now. So you have to have an extra friction when you are to put a card on next service, so people avoid that. By the way, I love all these services, right? But the strategy that the businesses take is bundle more services and lock people in. So it's very easy for you to get started, but in the long run, it may be expensive. So you can start easily, but exit is very difficult. So another startup story, when we consciously made decision about using all the serverless ecosystem, and we had to create all like event-driven services, eventual consistency. We were happy with the services that we used, so there was no regret as such. It was a conscious decision. We wanted quick time to market, so we ended up using AWS Lambda, we ended up using DynamoDB, Kinesis, all proprietary things basically. They are not portable. So our code was essentially not portable. And when we got an offer from other cloud, we did not want to migrate basically because it was working well for us. So I would consider that as a conscious decision. That was a strategy basically. And when you are getting a strategic win by using one specific cloud provider, or there are some services which only are available on given cloud, sometimes some specific services may be something to do with data, AI, ML, those kind of things are not generically available everywhere. So these suggestions don't apply there. So this is about your standard application development. So you have to be conscious or cognizant about the cost of making the changes because we spoke about what is lock-in, it's cost. So cost is highest at the lowest layer in this pyramid. If you look at data, if I were to change my database, it will be most expensive because I'll be changing the data model, I'll be changing the application code to access that data model. I might be doing some migrations and not the schema migrations, but migrating one data from one database to another. It might incur downtime. So it's the most costly thing. Application code is relatively simpler than data, but it's extremely difficult if you are porting from one cloud to another. Let's say if you are using AWS Lambda and you are to run it on some other provider, it will be difficult. You have to change or rewrite the code. And the higher up you go, build logic. It's just your Docker file. It should be just your Gradle files or NPM modules and all those. You can just swap without changing the code. A classic example could be your database driver or a JVM agent that you use for monitoring or anything like that, or your sidecars. So they are like all part of build logic. You don't have to change your application code. So the higher up you go, the lesser you spend basically. And the ideal scenario is just configuration change. I just change my database URL and everything works. That's like the utopia. So how do you design data layer to be vendor agnostic? In data layer, I include everything there, including database, blob storages like S3 or Google Cloud buckets, queues, pub/sub mechanisms, caches. So the products that you should ideally strive for using are something that work on multiple clouds. So as long as there is no strong reason to use something, as I said, like some data service or ML service that you are using that is only available on one cloud, then it makes sense. or we ended up using sometimes a Firebase kind of database because we needed real time, we did not have time. Our mobile app could not have been built without that. So in such cases, it makes sense, but ideally choose something that is open source, you can self-host it, deploy on any cloud. Types of services that you should be aware about are like 3 types of services, particularly unmanaged services, which you self-host, and then you have to worry about OS patches, security vulnerabilities, like upgrading the database, data formats, everything. Like for example, hosting Postgres on EC2. So that is that category. More often than not, people end up choosing managed services, which is a better choice, but choose managed service which is cross cloud available basically. So you can be using the same thing. Let's say I'm using Elasticsearch and the same thing is available on other cloud, so I'm fine, but I just don't want to manage the servers or clusters. So then it makes sense to use managed services. And the difference between serverless services is that they handle the scaling also for you. So you can scale to 0 or you can scale to infinity hypothetically, but without doing any changes. So you are following a pay-as-you-go model, so it might be costly if you have high workloads or a continuous traffic, but it's very cost-effective when you don't have a sustained load throughout. Again, another story, like, so I give example that let's use Postgres. It's like vendor-agnostic, I can use it on any cloud. In my next startup, we ended up using RDS/Aurora, and what happened is one or two of the teams, they ended up using the data API. Now, data API is something that AWS exposes as HTTP. So you have to write a post query or post HTTP post method, and then you specify the query inside post body, and then you get a very proprietary format result. Now that code, again, despite choosing AWS RDS, we ended up using code which was not portable. So don't do that unless you have very sound reason to do that. Application code, what should you monitor particularly on application layer? Like we were talking about data layer, but on application, taking the example from previous slide, that try to stick to something that is standard and across the databases or across the cloud that is available. For example, your JDBC connectivity. Instead of using data API, you might as well use JDBC, so that's a lot portable. For telemetry, you can be using OpenTelemetry rather than some vendor-specific extensions that you ended up writing in code. We were using, let's say, Xarray, and now our code was all littered with Xarray segment start and end and those kind of syntaxes. So if you are aware about what is tracing, you might begin a span and end a span. So those kind of code end up creeping into your code base, and now that's no longer portable. You could use static code analysis tools to detect what all dependencies are. Another example, like SES. So we ended up using SES, and for accessing the email service, there are multiple ways. You could be using the AWS SDK, SES client, or you could be using just the SMTP API. So prefer using SMTP API here because then your code is portable. If I move it to another cloud provider, I am just changing some environment variables. You might miss a feature or two, but that's the cost you are paying for using a portable code. Again, these are examples from like true stories. Another example, application password rotation. So you might have seen you have to rotate database passwords, particularly if you are in a kind of regulated industry. Let's say we are changing password monthly. So every time there will be some downtime when the database password changes. Now what ended up happening was developers were using AWS, of course. So they ended up using Secrets Manager, and they wrote code that accesses secret from Secret Manager. So this is kind of pseudocode that you get, that you are trying to get a connection, but for that you get credentials from Secret Manager, and if it fails, then you again get latest Secret Manager's credential. So now that way, the portable code, perfectly working fine, ended up being a very locked in code. So you can't just run it on another cloud. It's no easy problem. And another thing is you could just use some driver. AWS provides one driver that uses Secret Manager. So now we are moving dependency from application code to the build layer. So now my code does not change, but the driver changes, and I can swap that in my build file when I'm shifting the code base to another cloud, basically. Or better, just move it outside, like make it an environment variable only accessible to your code, and rotate that using your pod recycling or whatever mechanism. You can be using some portable cloud abstractions. A classic example is, let's say, S3. Now we end up writing code that accesses S3, and then the same code won't work on other clouds, right? So there are, in various languages, there are libraries available which allow you to have some abstractions which you write and just swap some configuration when you are shifting the cloud. So your code is agnostic. Let's say you are using S3, so it will be called a blob, and you fetch a blob, you change some configuration, move it to other cloud, you can still work. So the Go cloud is by Google itself, and that's a very nice initiative. But I don't have a very huge success stories with this. I have personally not used them a lot, but this is just for your reference if you could find a use of them. Or you can abstract out your vendor specific code. Typically what you do is you write business logic that directly accesses, let's say, Kinesis or Kafka in this case. Like Kinesis is only available on AWS in this case. So what I would do is I would write an interface. It could be as simple as put message and get message. But now I write two adapters for that, one using Kafka, one using Kinesis. And rest operational characteristics are still different, but that is at least not coupling my application code with Kinesis or Kafka. So as long as I can implement that interface, I am portable to other cloud. What kind of compute should you use? Ideally, I would say something that can run in container is always preferred. You should be able to run it locally along with its dependencies. So if I'm starting an app, I should be able to use Postgres, for example, in a Docker container or as a Docker compose, so that I know that I'm not ending up using something that is very, very specific to a cloud. If you are using Lambda, what we ended up doing there was use Micronaut, and that provides an abstraction so that the same code you can run locally, because running Lambda locally is very difficult. And then you are connecting to cloud also there. So it becomes extremely difficult there. For authentication authorization, don't use things like Cognito, for example. Instead, you can use something like Dex or Keycloak, which you can run locally. But of course, you have to consider about the management aspect of that. Always keep operations in mind, log in JSON format, use OpenTelemetry so that you are agnostic to the vendor. Use frameworks that emit the metrics by default. For example, Spring Boot emits a lot of good metrics by default, so might as well use that. Prefer your sidecars that can do the network and routing and a lot of other things for you, like caching and stuff. Don't do that inside code, so you only have to change the sidecar. The litmus test, if you have to take just one slide home, this is the one that I would recommend. You have to just answer these 4 questions for yourself. That can you develop locally without connecting to internet? Because most cloud providers will ask you, okay, connect to DynamoDB, but develop locally, right? So that will cost you. Use the same version of services that is being used in production. If I'm using Postgres for that example, am I able to run the same version locally that is being used in production? There is a concept called dev prod parity. So it's not about dev environment and prod environment, but even your local machine. Can I use same thing? And with containers, it's extremely easy to do that. Can I use all the things locally with Docker Compose? And can I host it to other cloud just with some configuration changes? The CI/CD layer is another thing which you should be considering about. There are numerous examples, and I don't have a preference here, not a strong preference. Unless you are doing something extremely complicated in CI/CD, it should be swappable essentially. But if you have complicated stuff, you can either use something like Jenkins or GoCD, or you can use something like Dagger or Earthly.dev, which allow you to port. Like Earthly and Dagger allow you to port your same code on multiple vendors, whether it is GitHub Actions, or you could be running on AWS Code Pipeline or anywhere. Finally, your choice of infrastructure as code, that is always going to, like, you have to write infrastructure as code again when you are porting to other cloud. Sadly, there is no such thing that I use this infrastructure code and that works exactly as is on other cloud. So, but at least you should choose those tools which makes you learn once and then rewrite everywhere. So you don't have to learn new tool every time. I'm just moving my code base from, let's say, AWS to GCP. If I'm using Terraform or Pulumi, then I'm just rewriting the code, but I'm not learning a new language like a CloudFormation or ARM templates in case of Azure. Summary, what do you do to choose the right stack? Like, first have like all the stakeholders part of that decision. Don't just decide in isolation. You choose anything that should work on major clouds and should be offered as a managed service ideally. It should provide a standard API like JDBC or SMTP to access it rather than some custom API. It should offer languages support, multiple languages support. It should be stable and well maintained. Ideally, you don't want something that is like deprecated or is not being updated in the last 5 years. Choose cloud services consciously, not accidentally. Containerize your services as much as possible. Think about the litmus test that I asked earlier, that can you run your entire stack without locally without costing you money. Make sure you can export your data easily. So whatever data choices you are making, make sure that is exportable, and prefer an agnostic, cloud agnostic or vendor agnostic IAC language. Of course, you will have to rewrite that. It's like saying you cannot write a shell script which works on Windows as well as, let's say, Mac. So it's same thing about cloud IAC particularly. And last thing, since I spoke so much about standards, I want to end the presentation with this slide that you should not do this thing basically. So just read it out. Thank you everyone.